This conference will now be recorded.
So yesterday notes somehow it is missing, like some problem with the notes part. Okay. So what we'll do is we'll just try to do all the things once again. So as I told you, Java is simple and easy to understand because Java uses the basic character set components, and I told you that Java is taken from the existing languages. Okay, so the existing languages like C and C++. Okay, so C and C++. So Java is said to be derived from the C and C++. So what all it has taken from C, it has taken the basic programming part. Okay, so the basic part, and from C++ it has taken the object oriented programming concept. So we'll talk about what is object oriented programming and object. So, and as I've told you, Java is a high level, so it is developed by using the basic character set and must be converted into machine level. Okay. Now, our understanding is what is this machine level? What are the different kind of conversion that we take place generally? Okay. So, for example, whatever you write in the program, so they will be converted into binary language or a machine language or a machine code, something like that. Okay, so now how exactly we will interpret, that, so how exactly we will interpret that kind of conversion, so that we will be understanding now. So now as I've told you, there will be four kind of binary things, or I can say four kind of numbers. Okay, so binary. Okay, so second one is decimal, and third one is octal, and fourth one is going to be hexadecimal. Fourth one is going to be hexadecimal. Okay, so when I talk about binary, so what exactly is binary, sir? So binary means the numbers that are formed, the numbers that are formed the numbers that are formed from 0 and 1. Okay, so the numbers that are formed from 0 and 1. Okay, so the numbers that are formed from 0 and 1. Then what are decimal? The numbers that are formed from the numbers that are formed from 0 to 10. Okay, so 0 to 9, sorry, 0 to 9. Okay, so 0 to 9. Now mathematically, what are these numbers, sir? So these are base 2 numbers. Base 2 numbers, so these are base 2 numbers. And coming to this, so these are base 10 numbers, base 10 numbers. And what about this? These are octal numbers. So octal numbers are formed by the combination of 0 to 7, so they are known as base 8 numbers. Okay, and finally when we talk about hexadecimal, the numbers that are formed by 0 to 10. And what is a? Actually, a is 10, b is 11, c is 12, d is 13. Okay, e is 14. Okay, so e is 14, and f is going to be 15. Okay, so these are base 16 numbers. So these are base 16 numbers. Okay, so base 2, base 10, base 8, and base 16 numbers. So what we are talking about here, we are talking about the types of numbers. We are talking about the types of numbers. So types of numbers, we have base 2, base 10, base 8, and base 16. Okay, so first what we will do is we will try to understand the decimal numbers. So what are decimal numbers? Because these are the numbers that we use in our daily life. In our daily life, for example, you are coming on a bike, let's say. So your bike number is something like 8384. So this 8384 is coming from where? Decimal only. Okay, so your hall ticket number, your bike number, bus numbers, train numbers, what are all this? All these are decimal only. So they are combination of 0 to 9. They are combination of 0 to 9. So suppose if we are taking something like 89. So what is 89? 89 is a which number? Decimal number. 89 is a decimal number. Getting my point? So what is 89 here? 89 is a decimal number. Clear or not? So when I am saying 89, so what is 89 here? 89 is a decimal number. 89 is a decimal number. So decimal number, how we can uh, call it? So we call it as 89 to the base 10. 89 to the base 10. Okay, so 89 to the base 10. So what we are trying to do here, so we are trying to say it is 89 to the base 10. So this is what we generally know in mathematics, isn't it? So we generally know in mathematics that it is which kind of number it is? It is base 10 number. So base 10 number. Understanding my point? So it is base 10 number. Okay. Now these are general numbers. So now our aim is to convert from decimal to binary. So what we need to go now and convert into binary. So 89 to the base 10 we will convert into base 2. 89 to the base 10 what will convert into? So we will convert into base 2. Understanding my point? Yes. So what is our aim now? Our aim is to convert 89 into what? 89 into 89 into what? Into base 2. Base 2. Okay. So what I told you yesterday. So I told you that. So what I told you yesterday. So I told you that the memory for numbers is minimum 8 bits. Minimum 8 bits. So this 89 will be converted into minimum 8 bits. Now for example you take a bigger number, so 8 bits may not be enough, so we have to convert that into 16 bits or whatever it fits. Is that clear? So we'll talk about that more bits later. For now we are talking about what? We are talking about 8 bits only, minimum 8 bits. Okay. Now what I have to do, sir? I have to go for, okay. So to convert decimal to binary, convert converting decimal to binary requires converting decimal to binary requires what? Requires division remainder theorem. Division remainder theorem we will divide by where we will divide by where we will divide by 2, divide by 2 and take the remainder and take the remainder. Okay, take the remainder. Sir, why sir you are dividing by 2? Because we need to convert into 2. We need to convert into 2. Getting my point? Okay. Now what we have to do, sir? We have to take this 89. Okay, so take this 89 and you divide by 2 and take the remainder. So 2 fours are 8. 2 fours are 8. What is remaining? 1 is remaining. Yes. So that 1 we will keep it later. So next to 2. 2 22 times. What is the remainder? 0. Next 2 11s. What is the remainder? 0. Next 2 5s. Remainder 1. So 2 2s. Remainder 1. 2 1s. Remainder 0. Okay. Until you get 0 or 1, you go on doing it. Yes. Okay. So 1. What I can keep here? 1 0 0. 1 1 0 1. So how many came? 1 2 3 4 5 6 7. So I have to keep it 0. Why have to keep it 0? Because it is a most significant bit. Most significant bit, if it is positive it should be 0. If it is negative it should be 1. So negative numbers we'll talk about later. For now just concentrate on the positive numbers. Now it is clear? Yes or no? Okay. Now if I have to convert, so convert binary to decimal. Binary to decimal. Okay, so you require exponent sum theorem. What theorem? Exponent sum theorem. Exponent sum theorem, where you will power by 2 and add the bit, power by 2 and multiply power by 2, comma, multiply the bit, multiply the bits, and take total sum. Take what? Total sum. So what I'm talking about, sir, here. Now what we'll do is we will take the same. We'll take this same. Okay, we'll take this same and we will convert that into decimal. Convert that into decimal. Understanding my point? So now take this 0, 1, 0, 1, 1, 0, 0, 1. So now what is this basically? This is bits. This is 8 bits. 8 bits. So how they are placed? 0, 1, 2, 3, 4, 5, 6, and 7. So how it is placed? 0 to 7. 0 to 7. Is it clear? Yes or no? Up to now clear? Okay. Now what I have to do? I have to do the power by 2, multiply the bit, and take the total sum. Now, what I have to do here, it is 2 to the power of 0 actually. So it is 2 to the power of 1. So it is 2 to the power of 2. It is 2 to the power of 3. This is 2 to the power of 4. This is 2 to the power of 5. This is 2 to the power of 6. This is 2 to the power of 7. Clear up to here? Yes or no? So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. Clear or not? Absolutely clear up to here? Okay. Now what I have done, power by 2 and multiply the bit. Multiply the bit means what? So I will take 2 to the power of 0 into 1. 2 to the power of 0 into 1. Yes? Okay, next 2 to the power of 1 into 0. So 2 to the power of 1 into 0. This 0. This one you have to take. Not this ones. So this one's already we have taken here. Right? Okay, next 2 to the
2 to the
power of
power
2
of
into 0.
0.
Next 2 to the power of 3 into 2 to the power of 3 into 1. Isn't it? 1. Next 2 to the power of 4 into 1. 2 to the power of 5 into 0. 2 to the power of 6 into 1. 2 to the power of 7 into 0. Clear up to here? Yes. So 2 to the power of 0 is this. This 1 is this. 2 to the power of 1 is this, and this 0 is this. 2 to the power of 2 is this, and this 0 is this. Clear? Yes or no? Okay. So 2 to the power of 0 is how much? 1. 1. 2 to the power of 0. Anything to the power of 0 is 1 only. So 1 into 1. What is 1 into 1? 1 into 1 is 1. 2 to the power of 1 is how much? 2. 2 into 0, 0. 2 to the power of 2 how much? 4. 4 into 0, 0. 2 to the power of 3 how much? 8. 8 into 1, 8. 2 to the power of 4 how much? 16. 16 into 1, 16. 2 to the power of 5 into 0, 0. 2 to the power of 6 into 1, 2 to the power of 6 how much? 64. 64 into 1, 64. So 2 to the power of 7 how much? 128. 128 into 0 is 0. Done. Now you add 6 plus 4, 10. 10 plus 8, 18. 18 plus 1, 19. So 6, 7, and 8. That's it. Proved it. We proved it or not? So we converted decimal to binary and binary to decimal. Clear now? Yesterday there was some confusion with you. Okay, now it is clear, crystal clear. Yes or no? Done? Okay. Now going to the next one. Now what we will do, so we will take decimal only because decimal is the base. Decimal is the base. Okay. So convert decimal to octal. Converting decimal to octal requires what? Requires division remainder theorem, where we will divide by 8. We'll divide by 8. Why sir 8? Because the base should be 8. Because the base should be 8. Yes or no? Okay. Now the same 89, what we are doing? We are going for dividing by 8. 8 11s 88. Yes or no? 8 11s 88. What is the remainder? 1. Okay. Next 8 ones are 8. So 8 ones are 8. So what is the remainder? 3. Okay. 800. What is the remainder? 1. Yes. Now how can I write this number? 1 3 1 and 0. 1 3 1 and 0. Is that clear? Yes or no? Okay. Now tell me how this 131 will be given as 1 3 1 and 0. Then what it is actually 0 1 2 and 3. 0 1 2 and 3. Clear? Understanding now? Yes. Up to now it is clear? Yes or no? Okay, fine. Now converting octal to decimal requires exponent sum theorem, where we will power by how much? 8. Power by 8 and multiply the bit to take the sum. Ah, అంతే. Decimal to octal you are dividing by 8. That's it. ఇంకా డివైడ్ అవ్వదు కదా. డివైడ్ అయ్యేంత వరకు డివైడ్ చేయాలి. డివైడ్ అవ్వనంత వరకు ఆపేస్తాం. క్లియర్? Clear or not? Okay. So now we are converting octal to decimal. So octal to decimal kavali ante what we have to do? So again you take this 1 3 1 and 0. So now as I told you, this is 0 1 2 3. ఇప్పుడు ఏమందాము 8 to the power of 0, 8 to the power of 1, 8 to the power of 2, 8 to the power of 3. Okay. Now 8 to the power of 0 into 1. Next 8 to the power of 1 into 3. Next 8 to the power of 2 into 1. 8 to the power of 3 into 0. Okay. Now tell me what is 8 to the power of 0? 1. 1 into 1? 1 only. 8 to the power of 1 is 8. 8 into 3? 24. Okay. 8 square? 64. 64 into 1? 64. Okay. 8 to the power of 3 is how much? 8 8 64, 64 fours, something like, okay, whatever it is. So into 0. Into 0 how much? 0. Right? 4 plus 4? 8. 8 plus 1? 9. 6 plus 2? 8. Done. Now 89, same 89 you got? Yes or no? So that is how we are dealing with the conversion of the octal. Conversion of the octal, and then again octal is converted into decimal. Is this clear? Okay. Then coming to the next one. So what is the next one here? Next one is going to be converting decimal to what? Hexadecimal. Hexadecimal, where we will divide by how much? 16. We will divide by 16. So here it should be 16. It should be 16. So converting binary to decimal requires exponent sum theorem, where we will power by 16, multiply the bit and take the total sum. It is as simple as it. Okay. Now same 89, as you know. So 89 we will divide by 16. So 16 3s are 48, 16 4 64, 16 5 is 85, correct? 16 5 is 85, correct? Okay. What is remaining? 4 is remaining. Okay. Again 16 0, it will be 5. Okay. Now the answer will be 4 5 0. Actually what happens is you need to put it as 0x, which is something like 0 only. Okay, 65 is 80. 80, yeah. So 80 means how much is remaining? 9, no? Okay, so 5 and 9. Okay, that's it. Then, okay. So how much is 65 is 80? Okay, 9. So here also you put it as 9. Okay, right. So now again same thing. Now don't take this into consideration. Only two are enough. So 5 and 9. So this is 0, 1. Now converting. Hmm. ఒక్క నిమిషం, ఒక్క నిమిషం, ఒక్క నిమిషం. చెప్పు. Okay, so now 89 we need to convert into hexadecimal. Okay, so hexadecimal, if you have to convert, what you have to do? You have to divide by 16. You have to divide by 16. 1 second. You have to divide by 16 and take the remainder. Take the remainder. So what I'll do now? I will go for 89. So 16 5 is 80. Correct. So what is remaining? 9 is remaining. So 16 0 0. What is remaining? 5 is remaining. Clear? Okay. Now what I can put it here? 9 5. Actually this is 0x. We can keep 0x. The rule in the sense hexadecimal will be always represented as 0x. 0x తో రిప్రజెంట్ చేస్తాం, లేకపోతే it will become normally normal number only, no? So it will become 59 డెసిమల్ నెంబర్ అయిపోతుంది. కాబట్టి కంప్యూటర్ ఏం చేసుకుంటుంది? జీరో అవసరం లేదు మనకు, అది ఏంటంటే ఓన్లీ రిప్రజెంటేషన్ మాత్రమే. ఇట్ ఈస్ ఓన్లీ రిప్రజెంటేషన్. సో ఇట్ ఈస్ నాట్ ఫర్ క్యాలిక్యులేషన్. దాన్ని ఒక జీరో అనుకోండి, తప్పలేదు. ఎస్. సో 0x అనేది జస్ట్ ఇంప్లిమెంటేషన్ కోసము. ఇట్ హ్యాస్ టు డిఫరెన్షియేట్. ఇప్పుడు నేను 59 అని రాశాను అనుకోండి, మీరు ఏమనుకుంటారు? ఇది డెసిమల్ అనుకుంటారు. అదే నేను 0x59 రాసిన అనుకోండి, ఇప్పుడు మీరు ఏమనుకుంటారు? ఇది హెక్సా డెసిమల్ అనుకుంటారు. అట్లా కంప్యూటర్ రికగ్నైజ్ ఇన్ దట్ వే అనమాట. 1059 అంటే 1 ఉంది కదా, 1 ఉంది. సో ఇప్పుడు 1059 ఉంది. 1059 ఈజ్ అ కాంబినేషన్ ఆఫ్ 0 to 9. కాంబినేషన్ ఆఫ్ 0 to 9. ఇక్కడ లెఫ్ట్ సైడ్ ఏం నంబర్ లేనప్పుడు మాత్రమే 0 పనిచేస్తుంది. లెఫ్ట్ సైడ్ ఏం నంబర్ లేదు కదా. సో ఇప్పుడు ఇక్కడ లెఫ్ట్ సైడ్ నంబర్ ఏమైనా ఉందా? ఇంకా నంబర్స్ ఏం లేవు కదా, ఇక్కడ 0 వచ్చేసింది. సో 0 ప్లేస్లో 0x పెట్టుకుంటాం అంతే. అర్థమైందా? సో జస్ట్ రిప్రజెంటేషన్ కోసమే. ఇట్ ఈస్ నాట్ ఫర్ ప్రాక్టికల్ యూస్. ఇట్ ఈస్ ఓన్లీ ఫర్ రిప్రజెంటేషన్. క్లియర్? ఓకే. బట్ వీ విల్ కన్సిడర్ దీస్ టూ ఓన్లీ, 5 and 9. సో 0x అనేది 0 అని అనుకోండి సింపుల్. 1059 అంటే అది డెసిమల్ అవుతుంది. మళ్ళీ 1059 విల్ బికమ్ ఏ డెసిమల్. అదే నువ్వు 0x1059 పెడితే అప్పుడు అది ఎక్సా డెసిమల్ అవుతుంది. అర్థమైందా? క్లియర్? ఓకే. సో నౌ దిస్ is 0 and 1. Okay, now what I have to do here? I have to go for 5 9. So this is 0, this is 1. 16 to the power of 0, 16 to the power of 1. So 16 to the power of 0, 16 to the power of 1. So ఇప్పుడు ఏమంటాము? 16 to the power of 0 into 9, 16 to the power of 1 into 5. Clear? So 16 to the power of 0 into 9, 16 to the power of 1 into 5. Clear or not? Sixteen to the power of 0 how much? 1. 1 into 9 how much? 9. So 16 to the power of 1 how much? 16. 16 5 is 80. 80 plus 9, 89. Done? Clear or not? Yes. So now what we have done? We have converted everything into we have converted everything into what? We have converted everything into binary to decimal, binary octal to decimal, decimal to octal, all kind of conversions we have done. Okay, now I'll give you one example. Okay, so take out your book, so and do it. Okay, so I'll give you the number. So let's say I will give you a number where I will say 174. Now you have to convert into binary also, octal also, hexadecimal also. Okay, yeah, do it.